Hello class, today we're going to talk about multiplying mixed numbers, but by the end of the lesson there will be a twist. So in order for us to do this, there is a prerequisite skill that we need to understand. How do you change a mixed number into an improper fraction? Well, many of you have learned a process in order to do this. What we used to call it is called the popcorn method. Some of you are familiar with this by saying it's around the world. Okay? Well, the popcorn method is nothing but taking the denominator, multiplying it by the whole part, adding the numerator, and putting it back over the denominator. So in this particular problem, we would do 3 times 4, denominator times whole part, add the 2, that gives you 14, and you put it back over the 3. Well, I want to show you what that really means. So back at the beginning, when we started mixed numbers, I had you draw me a picture of this. So 4 2/3, what that looks like. If I give a rectangle, and another rectangle, and another rectangle, all of about the same size, that represents the 4. Well, I also need 2/3 more. Okay, so if I take another one, chop it into the thirds, and I've got 2 of those. So that's basically what that means. Just kind of imagine these 4 are shaded in as well. So that's what 4 2/3 means. So when I change this into an improper fraction, I'm really taking this 3, I'm multiplying it by the 4. Well, what I'm really doing when I do that is I'm taking the whole parts and chopping them up into thirds. So 4 whole pieces chopped into thirds gives me 12 pieces. And then we add in the 2, and what size piece are they? They're still thirds. So we end up with 14 pieces that are all thirds. Okay, so that's basically what that really means. So that is a skill that we're going to need a little bit later on in our lesson today. Okay, so let's start off with some fraction problems. Start off with a real simple one here. It says, what does this problem mean? Well, this problem actually asks a question. 1/2 times 1/2 asks the question, what is 1/2 of 1/2? That's the question that it's asking. So if we look at this in picture form, well, if I have another rectangle and it says what is half a half, so I need to see 1/2. So here's my half. Well, what I want to know is what's half of that? So that means I cut this in half, and what size piece is that right there? Well, in the grand scheme of this picture here, the grand scheme of things, that's really one piece out of the 4 that are all that same size. So 1/2 times 1/2 is 1/4. That's what 1/2 times 1/2 means. Okay, what is 1/2 of 1/2? So if I do that one, what about this one? Here's another one. Well, this one asks the question, what is 1/2 of 1/4? So if I do the same question, if I do the same picture, I draw a rectangle. It says I start off with 1/4. So let me chop this into fourths. So here's my fourths. Well, I want to know what's 1/2 of one of those. What's half of that? I want to know what is that piece right there worth. Well, if I chop the rest of the fourths into the same size, that's actually one piece out of the 8. So we end up with 1/8. So what does that kind of look like that we're doing? So if we look at this last problem, we did 1/2 times 1/2, we got 1/4. This one we did 1/2 times 1/4, we got 1/8. What does it appear that we're doing? Well, it appears that we're multiplying our top numbers together and multiplying our bottom numbers together. 1 times 1 is 1, 2 times 4 is 8. So if that's the case, what are we going to do on this one? Well, in this one, if we look at it in terms of a picture, this one means what is 1/2 of 2/3? So if I were to draw the picture out, okay, give me 2/3. And I want to know what is half of that. Well, half of that is going to be 1 out of the 2 pieces. So half of that is this section right here, which represents 1/3. But I thought we just said that what it looks like, what it appears in these other 2 problems, is that I multiply 1 times 1 and 2 times 2 to get 4. 1 times 1 to get 1, 2 times 4 to get 8. But in this one, it means I should get 1 times 2 is, it's not 1. What is it? It's actually 2. And 2 times 3 is 6. So I did not get 1/3. But if we actually simplify 2/6 by dividing this by 2 and dividing this by 2, I do get back to 1/3. So it does work. So what appears to happen really does. What we're really doing is multiplying our tops together, multiplying our bottoms together. So with that in mind, I have a little thing to help us remember that process, and it's called the multiplication wrap. Okay, and here's how it goes. It goes like this. It says, to multiply fractions, you know you got them. It's top times top and bottom times bottom. And that's the multiplication wrap. Now this is verse 2 of a wrap that we'll finish learning on Thursday. Okay, so this is the multiply. We'll learn the division one on Thursday. Okay, now here's the thing. In this one, this first line is what is important, because it's what we call a conditional statement. It says to multiply fractions. The only thing I can multiply together is fractions. So what if I give you this problem right here? Well, these two numbers, are they fractions? No, they're not. These are not fractions. These are mixed numbers. But we just learned a few minutes ago how to change a mixed number into a fraction by doing the popcorn method or around the world. So could we do that with this problem? Well, let's see. This one right here we go. 4 times 3 to get 12, plus 3 to get 12, 13, 14, 15, back over the 4. Now it's a fraction. Times, do the same thing to this one. 5 times 2 is 10, plus 3 gives you 13 over 5. Now I have two fractions. So if I do this wrap here, it says to multiply fractions, do I got them? Yes, I've got them. So you know you got them. It's top times top and bottom times bottom. So all we do here, now once we have fractions, is multiply straight across. So 15 times 13 gives us 195. And 4 times 5 gives us 20. Now we end up with an improper fraction as our answer, so we must simplify that. Impropers, we simplify that through division. So we go to the side, we do 195 divided by 20. We ask ourselves, how many times will 20 go into 195? And you count it up if you need to, 20, 40, 60, and so on. You find out that it goes 9 times. So 9 times 20 gives me 180. We subtract, we get 15. Okay, so this 9, I write it as my whole part. My leftovers down here, that becomes my numerator. And the number I divided by becomes my denominator. So 9 and 15 twentieths. Now, am I done yet? No, because now we have to simplify again. But this type of simplifying is, what do these two numbers have in common? And this one is divide by 5, and we end up with 9 and 3/4 as my final answer. And that's how we multiply mixed numbers. Okay, so what if I give you one like this? Well, again, we go back to our wrap. To multiply fractions, do I got them? Well, I got one of them, but this one here I don't have. So I need to turn this one into an improper fraction, but this one I don't need to do anything with. So I take this one. 5 times 5 is 25, plus 2 is 27 over 5, times, and this one, like I said, we leave it alone. We do 4 times 9. Simple as that. Okay, so now we begin multiplying. So we do 27 times 4, and 27 times 4, I believe, is 108. Okay, because 4 times 7 is 28. Write down the 8, carry the 2. 4 times 2 is 8, plus 2 gives us 10. Very good. Okay, and then 5 times 9 gives us 45. Now again, it's an improper fraction, so we've got to simplify. Okay, so we ask ourselves, how many times will 45 go into 108? And it goes 2 times. So if you need to do the math, you come to the side and you divide. So 45 goes 2 times. That'll give us 90. We subtract that. We end up with 18. So we end up with 2 and 18 over 45. Okay, and then we simplify again because these two numbers have a 9 in common. So I divide by 9, and we end up with 2 and 2 over 5. Now, I'll be real honest. For me personally, I would never get 108 over 45 because there is actually another way that you can simplify. Okay? You could actually simplify within the problem first before you do any multiplication. So if I were to come over to this problem right here where we changed them into fractions and we ask ourselves the question, is there any top number that has anything in common with any bottom number? We find out that the 27 and the 9, they have a 9 in common. So if I were to divide the 27 by 9, I'd get 3. And if I were to divide the 9 by 9, I'd get 1. So now when I multiply, instead of getting 108, I actually end up getting 12. And instead of getting 5 times 9 to get 45, I do 5 times 1 to get 5. Now, which fraction would you rather work with, the 108 over 45 or the 12 over 5? Because now when I simplify this one, I could actually do this one in my head, whereas this one I might have had to do the division. How many 5s in 12? 2. How many is left over when I pull out those 2 5s? You end up with 2 left, and you'll notice that both of those you end up with the same answer. So you can simplify either your answer here, or you can simplify your problem here. And we'll be practicing more and more simplifying our problem. Okay? So let's see if we can have you do one by yourself before we throw a twist at you. Well, I think maybe this might be the twist here. No, no twist here yet. Okay, so in this one right here, what would I have to do? It says to multiply fractions. Do I got them? No, I don't have them. Okay, what do we have? Well, we have this one is a mixed number. So what are we going to do with it? Change it into an improper. Oh, but what about a whole number? How do I change it into a fraction? Well, all you have to do is stick a 1 underneath it. Then it's a fraction. So pause the video and answer this question by yourself. Okay, let's see how you did. So in this one, I'm going to change this one into an improper fraction. 9 times 7 is 63. Plus 5 gives me 68 over 9 times 3 over 1. Now, I'm going to practice this with the simplify problem. Okay? So I'm going to look at the top and look at the bottom and see, is there any number that has anything in common? Well, my 3 and my 9, they have a 3 in common. So I can divide this 3 by 3 and it turns into a 1. I can divide this 9 by 3 and it turns into a 3. Now I multiply across because there's not anything else. So 68 times 1 gives me 68. 3 times 1 gives me 3. Now, we still have to simplify it into a mixed number. So we ask ourselves, we do our division, or we come down to the side, divide. 3 goes into 6 2 times. So 3 times 2 is 6. Subtract 0, bring down the 8. 3 goes into 8 2 times. We get 6, we subtract. We end up with 2 left over. So our answer ends up being 22 and 2 thirds. 22 and 2 thirds. Now, that's how we multiply just plain old regular fractions and mixed numbers together. So what if I were to give you this one? What do you notice is different about this? Well, hopefully you notice that one of them is negative. Now we've got to bring in those rules again. So the first thing we do here is we think about, okay, if I've got one positive number and I've got one negative number, what kind of an answer am I going to have? With one negative, we know our integer rules say it's going to be negative. So now we go through, now that I know what sign's going to be on the problem, I now just multiply them just like I've been doing. How do I multiply these? Ask ourselves, is this a fraction? No, it's not. So I changed it into a fraction. So 4 times 6 is 24. 25, 26, 27 over 4 times, and then 5 over 9 is a fraction, so I leave it as such. Now I ask, are there any numbers on top and on bottom that could simplify? Yes, my 27 and my 9, they have a 9 in common. So I divide 27 by 9 and get 3. I divide 9 by 9 to get 1. Now there's not anything else I could simplify. If there was, then you simplify. So now I multiply. 3 times 5 is 15. 4 times 1 is 4. Now that's a lot better than the numbers that I would have gotten if I hadn't simplified. And now I divide. How many 4s in 15? 3. Okay, that gives me a total of 12. So I pull the 12 out of the 15. I'm left with 3/4. So my answer is going to be 3 3/4. But because of our original negative, it's got to be a negative 3 3/4. So all we have to remember is that when we're dealing with fractions and mixed numbers, that this first line is a conditional statement. To multiply fractions, I know I got them. It's top times top and bottom times bottom. Until next time.